Hey everybody, welcome to Testing Oban Jobs from the Inside Out. I'm Parker Selbert, known on GitHub, Twitter, and other parts of the internet as Soren2. I'm the chief architect at DScout, and I'm a partner in Soren, who are the people behind Oban. And you can see my wife, which is my partner in Soren, over there on the left. So DScout is hiring, much like everybody else here at ElixirConf. Soren is not, since it's just my husband and wife kind of thing. As you might have gathered from the talk title, we're going to be talking about a couple things today. First is Oban. So Oban is a persistent background job system, which means that the jobs or the work that you need to be done is persistent. And in this case, it's persisted in the database, a Postgres database specifically. And that's going to play a lot into how we're able to test Oban and the power that you have there. And then the other aspect is that it has many layered components. You can see a list there, queues, workers, plugins, and all these components interact with your application and your system as a whole. And we need to be able to control those to a certain extent to optimize our ability to do testing. And so this is going to be about automated testing, not just manual testing. And automated testing, in my opinion, and I think the opinion that is shared by a lot of the Elixir community, it's an essential component of reliable applications. And I'm going to define reliable as something that you actually want to be long-lived. You want to keep working on it, keep developing it, have other developers come in and help, and that you're probably going to change in the future. And in that case, automated testing is completely critical. And in that case, an application is complex and it has a lot of different moving parts. And it's essential that we verify that all those different parts are working together, all in unison. And so here's a simplified example, but it should show a little bit of the complexity involved, and that we have our application, and our application has context, controllers, whatever else is happening, but along with a number of workers. And workers are the Oban modules that do the business work, the things that you need to have done in the background. And then those are all connected to the database. And the database has a variety of different queues, and queues have jobs. So jobs are really just state that is tied to a particular worker later. And when we're testing, we'll focus on different parts of the application and the database. And where you happen to focus, that really depends on what your application does, the performance needs. If it needs to be isolated, if you don't want to be hitting AWS or something outside of that, and boundaries, just how much you want to separate your applications, your libraries, or your business logic as you go through and test layer by layer or module by module. And speaking of layers, this is what I call my recommended testing pyramid, which is an inversion of the historically taught testing pyramid. And the historic testing pyramid has unit tests on the bottom, the broad base, where you want to put most of your effort is at the small independent unit level. And then in the middle is integration, which is the glue between different modules or different components. And then typically acceptance is the smallest part. Acceptance would be something that exercises the full stack from a user's interaction all the way through the database and then back up. And here we're inverting it. So the recommended part is that you want to make sure that the full system works together and maybe don't focus so much on the unit level. But of course, based on isolation needs and performance, you're welcome to flip this or ignore the whole suggestion and only test at one level. That's entirely up to you. The important part, though, is that background jobs are always about some sort of side effect. You don't put something in a background job because you want it to work completely in isolation as a pure function. There's no value in that because nothing ever comes out of it. You don't care about some sort of return value. You care about what it's going to do. And that means it can be a little bit messy. It's going to impact your system in some way. Maybe it sends an email. Maybe it modifies the database. Maybe it processes media, like a video, or maybe it touches the file system. All of these things are potentially messy in that they're not part of a database transaction, or they could be slow just because they're outside of your control or outside of your system. or maybe they just complicate your state. It's too much to set up and too much to tear down. And in Elixir, we are blessed by XUnit and some amazingly powerful async testing. And while it's possible to turn that off, ideally, our great tests are async. And we're able to do that in a full application because we have isolation from these transactions. All of our individual tests run completely independently of everything else. And that gets a little bit complicated when you have a system that's doing background jobs that's part of your application, but also runs its own processes and is touching the database. And so to be able to use that and not mess with the rest of our system and have a lot of failing tests or just errors, we need to configure our application. We need to prepare it for using Oban. And the first and foremost part is playing nicely with Ecto's SQL sandbox. The sandbox is something that most applications run for test mode, and it means that you'll check out connections at the start of a test, and then your test owns that connection, and everything you do is inside of a transaction. And any interaction outside of that test with the database can cause trouble. And we don't want our layered parts of Oban, the plugins, the queues, we don't want that to actually impact our test. So if we take a pretty standard configuration, a very small one, with just a few queues, a few plugins, something that looks like this, we want to make sure that in test mode, our plugins don't run. They don't touch the database without our express knowledge or consent. And we don't want our queues to try to process anything either. So we just take that, and in our test config, we disable them. We just turn them off. And that gets us most of the way there. And now for all of the examples we're going to use, and just for some simplified testing, there's a testing module built into Oban. And it's ideal for unit and integration testing, and also part of acceptance tests typically. And adding that is as simple as a single line in your test helper. So this is a very idealized, simple test helper, but you can still see we have just this use module, and we pass the repo in. And that's important because the repo in our application is going to be used to do some assertions. The glue between the application and the database becomes really central later on. And we don't want to have to pass that in explicitly in all of our tests, so we just pass it in here. And that's all we need to do to configure Oban or your application to do some testing that's Oban aware. So let's get started. And as I mentioned before, we're going to start at the top of the pyramid, even though that's not where I necessarily recommend you focus your effort. It's just a lot easier to focus at the module level because everything here, it's just more isolated, and we want to build on complexity rather than building down from complexity. And so for unit testing, the unit of behavior that we care about is the worker. The worker is the module that we're going to focus on. And in particular, we care about the perform function, the perform callback on it. And there's a helper called perform job that does this. Perform job constructs a job and then passes it to the perform callback with a lot of validations in there. This is the type spec for it. You can see it takes just a few arguments of varying complexity based on how we use it. And we're going to do all of our examples from unit testing on in a TDD fashion. That means I'm going to introduce the test first, and then we'll run it, and we'll kind of follow whatever the prompts or the errors are and fix it from there. And in this system, super simple system, we just have an account, and you can sign up for accounts. And then we want to do some sort of follow-up on that. In this case, we're going to create an account for ElixirConf and with a fake email. And we want to know that when we call this worker, we pass in the account, it will then activate things. So to do that, we call perform job, we pass in the module, and we pass in an ID. And in TDD fashion, we're going to run this before we do anything else, and we expect it to fail. And of course, it does. We don't have an actual worker. And if we did, and it didn't satisfy the Oban worker behavior, we'd still get an error. So naturally, we want to go through, and now we're going to define an account worker. And so here is our very simple account worker. It's just got the one perform function on it with implementing that callback, and that's all we really need. And now that it's there, we can run it, and we expect it to work. And oh, no, of course it doesn't. Well, it might not be that obvious from this limited stack trace the error message, but we have a pattern match error. And in fact, the args are a string. You can see the ID is not an atom, it's a string. And that's what gets serialized and passed through. And that's because perform job is encoding something as JSON, just like it would be when it's put into the database, and then decoding it back from JSON, which means that we don't have atom keys for safety. So all we have to do now is go into the worker, change the ID to a string, run it again, and no, we still have failures. Well, it turns out Oban has specific things that it wants returned, such as an OK or these various tuples. But instead, we're getting this activated tuple with an account, and that is not what it wants, and so it's going to complain. So if we wrap it using with, just match on activated and convert that to an OK tuple, we should be fine. And now our tests pass without a problem. So that's great. What if we wanted to have a few other options, though? So maybe we want this to be a low priority. We have a lot happening in this queue, and we don't care if the activation happens right away. So we want to set it to a lower priority. We're going to choose something that seems really low, like 9, with 0 being the highest. Oh, well, when we run that, we see that there's a validation on these various options. Well, priority can't be 9. It has to be something between 0 and 4 or less than 4. We'll go back in and change it to 3. That should satisfy everything. Run our test again, and now it all works. That's all there really is to perform job. There's a lot in a single function that will validate all these different behaviors and functionality. It'll make sure that you're not passing things that aren't encodable, or you're using options that don't actually work, or if you have a custom callback or something that you can pass in arbitrary terms and those get converted properly. And it's all within that one single function. And it leads us to integration testing. So instead of just that one module, that one worker, now our unit of behavior is that integration point, that glue between the application and the database. That's essential that when we have requests coming in or we have some other context activation, that we want something inserted in there and we really care that it's the right arguments or that it's in the right queue. And to do that, we have some other helpers. There's one more helper in the testing module. We're going to focus on assert enqueued and refute enqueued, which take a variety of different contexts or different components, and then build up a query to make assertions on it. So continuing our TDD style, we're going to say we want to schedule activation in the future. So this is our activation worker that we tested before, but now we want to say that when the signup worker is called, the signup function is called, that it will enqueue something. And we use assert enqueued to do that. We pass through a few options. The name of the module, some args saying the account ID specifically, and maybe the queue. We go and run that, and we find that there's nothing in there. Well, that's kind of to be expected. We didn't actually add anything. We don't have anything that's running back there. And our signup worker, our signup function, we can go into the signup, and now when it's inserted, we then go and insert the Oban job. And now if we run it, we see that everything passes, and our test passes. It's as easy as that. But not all functionality is really that simple. Sometimes you have gen servers or other processes, something asynchronous, maybe a task, kind of like this. And those don't happen synchronously, which means that we can't have an immediate expectation in our test that something happened. So this is going to simulate that with a slightly contrived example where we just have a task that sleeps and then it inserts the job. Well, that's going to cause some trouble. When I go and run it, there's nothing in the database. I finished too quickly. So if we go back to our test, we can modify the test. We have the same expectations for all these different options, but we've added a new argument, which is that 150 at the end. So that means wait for 150 milliseconds. We expect that something in there will be added. This is much like a assert received, which is the built-in XUnit test assertion. And now when we run it, it waits. It happens to wait long enough, everything works fine. And on the flip side, we expect that when signup fails, if we pass in a blank email or something that's invalid, nothing should be enqueued. But we don't have to be quite as specific about the args. Of course, we don't have an ID, but all we really care about is that nothing in the worker category at all is added. And because we're running this in the sandbox and all of these are isolated, even in an asynchronous test, if other jobs or other tests are inserting an activation worker, this query is only going to run within our context, our current test process. And with the timeout and everything, we still get it to pass. Now we have both pass. So the enqueued helpers are excellent and ideal for querying the database. It helps automate some of the trickier queries you might have to write by hand, though you are able to do that. It's still a schema. It's still the ecto job schema that you could use and build things up. But checking for specific args and checking scheduled out times gets a little bit tricky. So we can work around that using the enqueued helpers. And that leads us to acceptance testing. For acceptance testing, now we're dealing with an entire application and the database and the workers, everything all together. And we really care that there's a flow of information from the application into the database, and then Oban's able to pull those things out, turn those jobs back into a worker argument, a worker module, pass everything through, and execute it. And to do that, we're going to use drain queue, which is something on the Oban module proper. And it has some pretty complex options and a nice result map. And that lets us really customize and tailor how we're executing the tests and make some powerful assertions on what actually happens when we're running those tests. And very importantly, it's all synchronous. It happens in a blocking way in our test process as we're running. And you might have noticed everything was supposed to be in the testing module, and it's not. This is something that is ideally suited for testing, but it is available if you want to drain queues in development or production. You can do it in other environments as well. And back to our tests. We're going to sign up, and in this case, we expect that there's going to be some sort of follow-up welcome email. And critically, we want to know that that email was actually sent to the right place with the right message, and that's all built on that account that's coming back. And to do that, we have to have the data pass all the way through. To do that, we need to execute the job that's put into the queue. So we use drain queue, and we give the mandatory argument of the queue to do emails, and we expect that one job came through. That's the success one there. One job successfully executed. We go and run this, and of course, that didn't work. We can see from the map, the result map that's coming back, nothing actually worked. 0 jobs. So let's go into our sign up function, and where before we were using Oban insert, now we use Oban insert all. We give it 2 jobs. Do note this one's scheduled in the future. And here's our worker that goes through, pulls something out of the, pulls the account out, and then generates the email and delivers it. And when we run this, it still fails. You can see nothing ran. Not only do we have no successes, there are no failures either. And that's because, as I noted, we're scheduling it in the future, and drain queue only runs something that's immediately available. So we want to tell drain queue, go ahead and schedule everything, take everything that's scheduled and make it available before running. We pass with scheduled true to do that. Now I see 0 success, but I have 1 failure, and something happened while the job was processing, and that error was recorded in the job on the errors field, but we didn't see it in the test because it was swallowed, it was rescued. And in that case, we want to say with safety false, and that will let us run inline and bubble up whatever that error or that catch, whatever tripped, will come all the way up, and then we can see it in our test run. So we run again. Now we can see there's a match error. Oh, there's a problem in the worker itself, and it's getting some sort of match that it shouldn't. And if we look at that line where the error is coming from, we see we expected an OK tuple, and we're using repo.get. And repo.get doesn't return a tuple, it just returns a single argument. So, or a single value. So here we just get that single value out with no worry about nil. Don't worry about that. And we go and run it, and everything works fine. Well, what if we take that a little farther, and now instead of sending 1 welcome email, we want to start a whole drip campaign when somebody signs up. We expect that our job is going to insert 4 emails, or 4 jobs, 3 of which are mailer jobs. If I go in there and I can see in our insert all, where before we were just activating, now we expect to enqueue these other jobs. So we have a hello, an intro, and a nudge, and they're kind of staged out an hour, a day, a week. We go and run it, and we only have one job that runs. And that's because while that job was running, drain queue didn't see anything else to run. We need to tell it to keep recursively running until there's nothing else to do. And so there we can use the with recursion flag. The recursion will just keep it going until there are no more jobs left to process, whether they're scheduled or not. And taking that and running it, oh, beautiful. Everything works as we expected. Drain queue is really valuable in any form of acceptance testing, or even when you're testing a particular module. If you have something that you expect to insert jobs and you want to verify all the way down that they work, it's valuable for that as well. But it's critical when you want to exercise the full stack and all the glue in between them, especially if you care about surfacing job errors and other things that are pretty tricky to do if you're trying to troubleshoot what's wrong with a particular worker, or if you want to put in something that's a regression test for some known bad arguments. Drain queue is really valuable. And that leaves us with one other form of testing, which was not included in the pyramid. And that's because it's not really part of a standard testing format. In this case, it's when you absolutely have to run jobs normally during your tests. If you have some sort of automated test suite that's going to run Wallaby on the front end, you're going to do full stack browser testing. And in this case, you want to keep everything at the browser level, or assertions about what's in the DOM, what's on the page. And in that case, you want things to just cycle through as they normally would. Or the same applies to live view. And if you thought you were going to get out of a talk, ElixirConf 2021, without hearing live view, I'm sorry, you're wrong. I got you. So to do that, we have to start by changing the name. So this is our test helper from before, or sorry, our test config from before. And we're changing it from the default name of Oban to Oban disabled. And that's because within our individual tests, we want to start up a separate supervisor, and there will be a conflict on the name. So in this case, we're going to have something that just runs in the background and doesn't actually do anything. And that lets us, within the setup function, start a supervised queue, a supervised process. Now, their start supervised is built into XUnit. We're defining our own helper. And it's critical that we do it in the test and not before in our application, because that means that it has access to the connection that's checked out by Ecto's sandbox. And start supervised Oban is a helper that does not ship with Oban itself, but it's something that you could build pretty easily. And that's partially because it's a little opinionated and not something I necessarily recommend doing, but it's great if it's a necessity for your application. And one of the first important things to point out is that rather than having no plugins, we have the repeater plugin. And the repeater plugin means that each queue will just poll every 25 milliseconds to look for new jobs. And the reason that we have to do this is because within the sandbox, everything runs in a transaction. And in a transaction, there are no pub sub notifications. And so as jobs are inserted, the trigger in the database that would normally tell your queues there's a job to run, those will never fire because it's in a transaction, and pub sub messages don't run until afterwards. So this is essential for that. And secondarily, we want to just tell the queues, don't bother polling separately because we're already having this quick poll. And when your test is over, shut it down within 25 seconds. And that stops it from hanging for longer than you would want. If a test is going too long and you want your application to shut down, rather than waiting 15 seconds for the process to finish, we only wait 25 milliseconds. And then also crucially, we pass in a specific ID, which is the name. So if you want to have multiple processes running at the same time, they will each have to have some unique different name, which here will default to Oban. But if you want them side by side, you'll have to give something specific because the system can't have that many supervised processes, more than one supervised process with the same name. So supervising or start supervised as a helper is great if you want to just pretend that your application's running as normal. But note that if you do it, you lose a lot of the functionality and the possibilities of isolation, control, scheduling, all of the things the other helpers give you, or that more isolated integration style testing would give you. And so I don't recommend that, as noted before, but it's available as kind of a backdoor if necessary. So critically, I don't care how you do the jobs, but just write tests for your open jobs. And most systems that do use background jobs put some really important logic in there. And it's crucial that you are able to exercise something from the top down, from the point where arguments come through a controller or GraphQL endpoint all the way through to the job, and that you can verify the full flow. So whether you happen to do that from an outside in or inside out perspective, that's totally up to you and based on the performance and the way that you have your application set up. So thank you for listening. If you happen to be really into Oban and testing, we do a lot of that at DScout. And as I mentioned earlier, DScout is hiring. Or if you rely on Oban for your application, please consider sponsoring the project so that we can keep adding great documentation, great helpers, and other functionality for things like web and pro. Thank you.
Thank you so much, Parker, for your talk. It was super interesting. I will stop sharing your screen so you can go to the chat because we have a question from James Rasmussen, and kind of got answered by the other folks on the chat, but if you want to take a look, it would be great.
I'm scrolling back up to see it.
Yeah, I can read it to you. Did you go to it?
Okay. Well, so the waiting for X milliseconds is really just waiting until something is queued in the database, not for how long it happens to run. When it comes to running something, that happens all synchronously. And the goal of most of the testing helpers is so that you aren't doing anything asynchronously that you don't need to, so that you have control over when it runs, how long it runs. So if, for example, your job was doing something that you expected to only take 100, 200 milliseconds, you could pass in a PID or something and have it send it back to your test process and then make an assertion that it gets there and use the XUnit assertion handlers, helpers, so that you don't wait too long. This is a problem in some of the web or pro tests where something that I happened to just fix yesterday, there was an error happening in the database, and the fact that I didn't make it too short, there was too long of a delay there. It meant that the test took over 9 seconds. And when I changed it so that it wouldn't delay so long, figured out what the actual issue was and that it was being rescued in some place, and then was able to swallow it and fix the problem. And then the tests ran in less than a few milliseconds, so there was no problem.
Cool. Thank you so much. Do we have another question? Okay, seems like not.
It looks like there's one from Mike Zornek about a catch. I don't know if that's a question or just kind of a statement.
We can go ahead with that one.
Okay. Yeah. Yeah, the terms, that's partially why the perform job helper was added. Originally, in the around 1.0, Oban would just allow anything. So it didn't really care about the return type. And it wasn't until it would only care if you raised something. And that wasn't very powerful. And that was prior to discard or snooze. And when those became powerful tools that were added, it became a lot more important to match on whatever the functionality is. So that's when the perform job helper got added. Well, so it wasn't a question, but I did comment anyway.
That's great. Thank you so much. Well, thank you, Parker. Thank you so much for your talk. It was super interesting. I hope everyone else is enjoying ElixirConf. And if anyone else has another question for Parker, feel free to reach out to him during this conference. He will be around. Thank you so much again. See you.
Everybody.